Select the appropriate model for the data. Is it linear? Is it quadratic? Is it cubic? This is what you're looking for. In order to find out from a table if something is linear, quadratic, or cubic, you need to find the rate of change as long as these guys go up by the same number. That's called equal length input value intervals. So if something's going to be linear, that means to get from 4 to 15 and from 15 to 50 and from 15 to 121, these have to be the same number. Well, to get from 4 to 15, you add 11. To get from 50 to 50, you add 35, which means right off the bat, it's not linear. This one has you adding 71, this one has you adding 119, and this one has you adding 179. So is it linear? Nar. Nar, as my friends from down under would say. Let's try it again. If it's quadratic, then the rate of change of the rates of change are going to be the same. So how do we get from 11 to 35? Add 24, of course. And from 35 to 71, add 36, of course. So it's not going to be quadratic because these numbers are different. So you add 48, you add 60. So it's not quadratic. So in order for something to be cubic, the rate of change of the rate of change of the rate of change has to be the same over equal length input value intervals. So how do I get from 24 to 36? Add 12. How do I get from 36 to 48? Add 12. How do I get from 48 to 60? Add 12. Is it cubic? Yep. So this is cubic because the rate of change of the rate of change of the rate of change are the same over equal length input value intervals. Isn't that fun?